5-2, day 2. A lot of times day 2 is a lot easier than day 1. It's just different looking problems built on the same concept as the first day. And that happens to be true here. So let's get started. Basically what we're doing is we're adding like terms. And what you guys might be used to is stuff like this. 2x plus 4x is 6x. 3y and 7y gives me 10y. Pretty simple. Take that same concept, apply it to radicals. We got 2 square root of 2 plus 4 square root of 2. That's like 2 bananas plus 4 bananas is 6 bananas. Remember when we multiply the square root of 2 times the square root of 2, that turns into the square root of 4, which is 2. The roots fly off. Not when you're adding. 3 square root of 3 plus 7 square root of 3 is 10 square root of 3. Same problem as this. It's just here you got variables, here you got radicals. So what are your homework problems going to look like? This. And at first glance you're like, I'm done. There's no like terms. Well, under further investigation, the square root of 20 can be broken down into 4 and 5, which is 2 square root of 5. Cubic root of 18 can break down into 8 and 2. Let's get the minus. 2 cubic root of 2. These are not like terms. Square root, cubic root of 250, and you'll get better at these. 125, 2 plus 5 cubic roots of 2, and then this little guy on the end, square root of 5. Where I got 2 bananas minus 1 banana is 1 banana. I didn't have to put the 1 there. Negative 2 cubic root of 2 plus 5 cubic root of 2 would be plus 3 cubic root of 2. And you can't go any further because these are not like terms. Two more. That's it for the pre-lesson. Here we go. Well, remember this is oil, this is water, but I have to multiply them, but I can't. They don't mix. So how do I show that they're being multiplied? The coefficient goes out in front, the radical goes in the back, and now I got this situation where I got like indexes, so I can multiply the stuff in here. Two ways to do this. Number one, just mash them. So we get the square root. 49 times 7 is 343, and that's the cubic root. And I'm like, wait a minute. Now, I don't think that's probably recognizable to you guys, but if you take your calculator and you bang out 7 times 7 times 7, you'll get 343. So my answer is that. Now, what if you were like, well, I don't think I'd recognize that. Here's a different way to do it. Remember, if I go square root of 2 times the square root of 2, I get 2. If I go the cubic root of 2 times the cubic root of 2 times the cubic root of 2, I get 2. Because 2 times 2 times 2 is 8. Cubic root of 8 is 2. 3 of a kind, need them if the index is 3 for the roots to fly off. With that in mind, what if I looked at this differently and I said, okay, I got the cubic root of 7 from here. And if I notice that 49 is just the same thing as 7 times 7, so I just got a little creative with the 49, and now I look at this and I go, hey, the roots fly off. Done. Stick a fork in it. I like that method. I just do. Last problem. What's the problem here? Well, we got a radical in the basement. Remember, you guys are well accustomed to problems like this. You're like, got it. I'm going to multiply that by the square root of 5, that by the square root of 5, so I get the square root of 5 over 5. Done. Hopefully you're getting good at that. Different situation. I've got a 2 plus the square root of 5. So if I stuck with that program, and I went square root of 5, hoping that it does the job, am I still on the board? I'd get the square root of 5 in the top. There's a 1 there. But then this times this would give me a 5, which is good. But then this times this would give me a 2 square root of 5. And I'm like, dang, that didn't get rid of the radical in the basement. This is where 1 over 2 plus the square root of 5, your good friend, the conjugate, comes into play. You take this binomial, multiply it by its conjugate. That's the fancy name for the same thing, you just switch the sign. Why does it work? I'll show you. And then you gotta do the same thing for the top. So let's take care of the top, because this times 1 is just itself. So that's my numerator. But here I'd FOIL this out. 2 times 2 is 4. Outside, negative 2 squared root of 5. Inside, positive 2 squared root of 5. That's why this method works. And then a negative times a positive is negative. Square root of 5 times square root of 5 is technically the square root of 25, which is just 5, or the roots fly off. These cancel. 4 minus 5 is negative 1. Now this gets kind of deep, but if I said 1/7 plus 1/7, I said add them, I hope you guys could go 2/7 because you have common denominators. But if I had this, 3/7 plus 2 over negative 7, technically, do I have common denominators? No. So you'd have to bring that negative up. And you're like, now I do. So 99.99% of the time, math is going to bring the negative up. It just makes life easy. So with that in mind, we'd say, oh, that's 1/7. How does that apply to this? Notice we have a negative in the denominator. We could just leave it. It's not wrong. It's just not quite simplified. So what they do is they take that negative and they bring it up top, but it has to multiply by everything. So it'd be negative 2 plus the square root of 5. This would be your simplified answer of your original problem. That's it for your pre-lesson. Don't skip those sample problems.